Welcome back to my channel LinkedIn Pharma. Class 7, Chapter 9, Motion and Time. Introduction of Motion and Time. Motion. Motion refers to the change in position or location of an object with respect to a reference point over a period of time. It is a fundamental concept in physics and can be described in terms of speed, velocity, and acceleration. Motion can be categorized into different types based on the path an object takes and its characteristics during movement. Examples of motion. Linear motion. When an object moves along a straight line, it exhibits linear motion. A car moving on a straight road or a ball falling vertically under the influence of gravity are examples of linear motion. Circular motion. Circular motion occurs when an object moves along a circular path around a fixed center. A rotating fan or a planet orbiting around a star demonstrates circular motion. Projectile motion. Projectile motion occurs when an object is thrown or projected into the air and follows a curved path under the influence of gravity. Examples include a baseball thrown by a pitcher or a cannonball shot from a cannon. Time. Time is a fundamental dimension that measures the duration between events or the interval between 2 points in the past, present, or future. It allows us to sequence events and understand the order in which they occur. Time is often measured in seconds, minutes, hours, days, and so on, depending on the context and scale. Examples of time. Clock time. Clock time is the most common way of measuring time, using hours, minutes, and seconds. For example, 12 p.m., 3:30 a.m., or 5:45 p.m. are representations of clock time. Geological time. In geology, time is used to describe the vast durations of Earth's history. Epochs, periods, and eras are units used to represent geological time. For example, the Jurassic period, which lasted from about 201 to 145 million years ago. Reaction time. In sports and everyday activities, time is often used to measure reaction times. For example, how long it takes a sprinter to react to the starting gun or how quickly a driver hits the brakes after seeing a stop sign. Travel time. When planning a trip, time is used to estimate how long it will take to reach a destination. For instance, a road trip from one city to another might take 5 hours. Both motion and time are crucial aspects of our understanding of the physical world, and they are interconnected in various ways. Time allows us to measure the duration of motion or the time it takes for an object to travel a certain distance. The relationship between motion and time is fundamental to concepts such as speed and acceleration. Some examples of different types of motion. Rectilinear motion. This type of motion occurs when an object moves along a straight line. A car moving in a straight path on a highway or a person walking in a straight line are examples of rectilinear motion. Curvilinear motion. Curvilinear motion happens when an object follows a curved path. A roller coaster moving along its track or a basketball being thrown in an arc are examples of curvilinear motion. Uniform motion. Uniform motion is when an object travels with a constant speed in a straight line. If a car drives at a steady 60 miles per hour on a straight road without changing its speed, it exhibits uniform motion. Non-uniform motion. In contrast to uniform motion, non-uniform motion occurs when an object's speed changes during its motion. For example, a cyclist pedaling uphill and then coasting downhill experiences non-uniform motion. Circular motion. Circular motion takes place when an object moves along a circular path around a fixed center. The motion of a spinning top or the moon orbiting around the Earth demonstrates circular motion. Oscillatory motion. Oscillatory motion is repetitive back and forth movement around a central point. A swinging pendulum or a vibrating guitar string are examples of oscillatory motion. Rotational motion. Rotational motion refers to the spinning or turning movement of an object around an axis. When a wheel rotates on its axle or a merry-go-round spins, it exhibits rotational motion. Translational motion. Translational motion is when an object moves from one point to another without rotation. When you slide a book across a table or kick a football along the ground, it undergoes translational motion. Random motion. Random motion occurs when an object's path is unpredictable, and it moves without any specific pattern. The movement of gas molecules in the air or the motion of dust particles suspended in water showcases random motion. Projectile motion. Projectile motion occurs when an object is launched into the air and follows a curved path under the influence of gravity. Throwing a ball upward or shooting a cannonball are examples of projectile motion. These are just a few examples of the various types of motion that objects can exhibit in the physical world. Understanding these types of motion is essential in fields like physics and engineering to analyze and predict the behavior of objects in motion. Slow and fast. Slow and fast are relative terms used to describe the speed or rate at which something moves, changes, or occurs. What is considered slow in one context may be considered fast in another, depending on the reference point or comparison being made. Here are some examples to illustrate the concepts of slow and fast. Slow. Walking. Walking is generally considered a slow mode of movement compared to running or driving. For example, if you walk from your home to the nearby store, it might take you 15 minutes. Growth of plants. The growth of plants is a slow process that occurs over days, weeks, or even months. For instance, it may take several months for a tiny seed to grow into a mature fruit-bearing tree. Internet connection. When you have a slow internet connection, web pages may take a long time to load. You might experience delays while streaming videos or downloading files. Aging. Aging is a slow and gradual process that happens to living organisms over time. For example, it takes years for a baby to grow into an adult. Fast. Running. Running is a fast mode of movement compared to walking. A professional sprinter can cover 100 meters in just a few seconds. Chemical reactions. Some chemical reactions occur at a fast rate, producing results in a short period. An example is the rapid reaction between vinegar and baking soda, which causes a fizzy reaction. Internet download speed. When you have a fast internet connection, web pages load quickly, and large files download in seconds. For instance, you can download a high-definition movie in just a few minutes. Bullet train. High-speed bullet trains can travel at incredibly fast speeds, covering long distances in a fraction of the time it would take by conventional trains. Remember that what is considered slow or fast can be subjective and context-dependent. For instance, what may be a slow car to one person might be considered fast to another person who is used to slower vehicles. Speed is relative, and it's essential to consider the specific context and reference point when describing something as slow or fast. Speed. Speed is a measure of how fast an object moves, and it is defined as the distance an object travels in a given amount of time. It is a scalar quantity, which means it only has magnitude and no direction. The SI unit of speed is meters per second in the metric system, but it can also be expressed in other units like kilometers per hour or miles per hour, depending on the context. Formula for speed. The formula for calculating speed is speed equals distance divided by time, where speed is the rate of motion of an object in meter per second, kilometer per hour, mph, etc. Distance is the total distance covered by the object in meters, kilometers, miles, etc. Time is the total time taken to cover that distance in seconds, hours, minutes, etc. Speed is a fundamental concept in physics and everyday life. It helps us understand how quickly or slowly objects move and is used in various fields such as transportation, sports, and scientific research. By calculating speed, we can compare the rates of motion between different objects and analyze their performance or efficiency. Measurement of time. Time is measured using various units, and its measurement depends on the context and the scale of the time interval being considered. The standard unit for measuring time in the International System of Units, SI, is the second. However, there are several other units used for different purposes. Time measurement is essential for organizing our daily lives, coordinating events, conducting scientific experiments, and understanding historical and geological processes. It serves as a fundamental dimension that allows us to sequence events and quantify the duration between them. Simple pendulum. A simple pendulum is a basic and idealized mechanical system consisting of a mass, called the bob, attached to a fixed point by a string or rod. When displaced from its equilibrium position and released, the bob oscillates back and forth due to the force of gravity acting on it. The motion of a simple pendulum is governed by principles of classical physics and is used to study oscillatory motion and timekeeping. Bob. In the context of a simple pendulum, the bob refers to the mass that is suspended from the fixed point by the string or rod. It is usually a small, dense object with significant weight compared to the string or rod's mass. The bob's motion is what gives rise to the oscillations in a simple pendulum. Oscillatory. Oscillatory is an adjective used to describe a back and forth or repetitive motion around a central point or equilibrium position. A simple pendulum exhibits oscillatory motion because the bob swings back and forth, alternating between one extreme position and another, due to the restoring force of gravity. Oscillation. Oscillation is the noun form of oscillatory, referring to the act or process of oscillating. It describes the repeated back and forth movement of an object or system around its equilibrium position. In the context of a simple pendulum, oscillation refers to the continuous swinging motion of the bob. Time period. The time period of a simple pendulum is the time it takes for one complete oscillation, which includes moving from one extreme position to the other and returning to the starting point. It is the time required for the pendulum to complete one full cycle of its motion. The time period of a simple pendulum depends on its length and the acceleration due to gravity. In summary, a simple pendulum is a mass, bob, attached to a fixed point by a string or rod, exhibiting oscillatory motion with a regular time period. The motion of the bob as it swings back and forth is a fundamental example of oscillatory behavior in physics, and the time period is a crucial characteristic used to describe its behavior. Simple pendulums have been historically used in timekeeping devices, such as grandfather clocks, due to their regular and predictable oscillations. Units of time and speed. Units of time. Time is measured using various units, depending on the context and the scale of the time interval being considered. The International System of Units (SI) provides the standard units for time, but there are also other units commonly used in everyday life. Here are some of the main units of time. Second. The second is the base unit of time in the SI system. It is the standard unit for measuring small time intervals and is defined as the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. Minute. 1 minute is equal to 60 seconds. It is commonly used for everyday time measurements, such as in cooking, meeting durations, or as a unit for measuring angles, examples, in degrees and minutes. Hour. An hour consists of 60 minutes or 3,600 seconds. It is widely used for timekeeping, scheduling, and various activities. Day. A day is the time it takes for the Earth to complete one full rotation on its axis. It is divided into 24 hours and is used as a common unit for organizing calendars and planning daily activities. Week. A week consists of 7 days and is used for organizing work schedules, planning events, and religious observances. Month. A month is a unit of time based on the moon's phases. Different months have varying lengths, ranging from 28 to 31 days. Year. A year is the time it takes for the Earth to complete one orbit around the Sun. It is divided into 12 months and is the basis for organizing long-term events and recording historical time. Decade. A decade is a period of 10 years. Century. A century is a period of 100 years. Millennium. A millennium is a period of 1000 years. Units of speed. Speed is the measure of how fast an object moves, and it is calculated as the distance traveled per unit of time. There are different units of speed used around the world, but the most common ones include meters per second. This is the standard unit of speed in the International System of Units (SI). It represents the number of meters traveled in 1 second. Kilometers per hour. Kilometers per hour is commonly used in many countries to measure speed, especially in the context of vehicles and road speed limits. Miles per hour. This unit is commonly used in the United States and some other countries to measure vehicle speed and speed limits on roads. Knot. The knot is used in maritime and aviation navigation and represents 1 nautical mile per hour. These units of time and speed are essential for various aspects of daily life, scientific research, transportation, and many other fields where measurements involving time and motion are required. Measuring speed. Speed is calculated as the distance covered by an object divided by the time taken to cover that distance. The formula for calculating speed is speed equals distance divided by time, where speed is the rate of motion of an object, measured in units like meters per second, kilometers per hour, miles per hour. Distance is the total distance covered by the object, measured in units like meters, kilometers, miles. Time is the total time taken to cover that distance, measured in units like seconds, hours, minutes. Examples of measuring speed. Car driving. Suppose a car travels a distance of 300 kilometers in 5 hours. To find the speed of the car, we use the formula. Speed equals 300 kilometers, 5 hours equals 60 kilometers per hour. So, the speed of the car is 60 kilometers per hour. Running athlete. If an athlete runs a distance of 100 meters in 10 seconds, we can calculate the speed as follows. Speed equals 100 meters, 10 seconds equals 10 meters per second. The speed of the athlete is 10 meters per second. Airplane flight. Suppose an airplane covers a distance of 800 miles in 2 hours and 30 minutes. First, we need to convert the time to hours. 2 hours and 30 minutes equals 2.5 hours, and then calculate the speed. Speed equals 800 miles, 2.5 hours equals 320 miles per hour. The speed of the airplane is 320 miles per hour. Bicycle ride. If a person rides a bicycle for 5 kilometers in 30 minutes, we calculate the speed as speed equals 5 kilometers, 0.5 hours equals 10 kilometers h. The speed of the bicycle ride is 10 kilometers per hour. These examples demonstrate how to use the speed formula to calculate the rate of motion for different objects in various scenarios. Speed is a fundamental concept in physics and everyday life, helping us understand how quickly or slowly objects move and allowing us to compare the rates of motion between different objects. Speedometer. A speedometer is an instrument found in vehicles that measures and displays the current speed at which the vehicle is traveling. It is an essential component of the dashboard and provides real-time information to the driver, enabling them to monitor and control the vehicle's speed. The speedometer is calibrated to show speed in various units, such as kilometers per hour or miles per hour, depending on the region and the vehicle's origin. The speedometer operates using a combination of mechanical and electronic systems. In older vehicles, it was entirely mechanical and connected to a cable that was driven by the rotation of the vehicle's wheels. Modern vehicles typically use electronic sensors to measure wheel speed, and the data is processed and displayed electronically on the dashboard. Odometer. An odometer is another instrument located on a vehicle's dashboard, and it is used to measure and display the total distance the vehicle has traveled since it was first put into use or since the last time the odometer was reset. It provides an accumulated reading of the vehicle's mileage and is a critical factor in determining the vehicle's overall wear and tear. Like the speedometer, the odometer can be mechanical or electronic. In older vehicles, it was primarily mechanical and worked in tandem with the speedometer's cable, registering the rotation of the wheels. In modern vehicles, it is more commonly electronic and integrated into the vehicle's onboard computer system, which records the distance traveled using various sensors. The odometer reading is often used by car buyers to assess the vehicle's age and condition, and it plays a role in determining the vehicle's resale value. In summary, the speedometer measures and displays the current speed of the vehicle, allowing the driver to maintain a safe and legal driving speed. The odometer, on the other hand, records the total distance the vehicle has traveled over its lifetime or a specific period, providing valuable information about the vehicle's overall usage and wear. Both instruments are essential for safe and efficient driving and vehicle maintenance. Distance time graph. A distance time graph, also known as a displacement time graph, is a graphical representation that shows the relationship between the distance an object travels and the time it takes to cover that distance. It is a useful tool for visualizing an object's motion and understanding its speed and direction. In a distance time graph, the x-axis represents time, usually measured in seconds, minutes, hours, or other time units. The y-axis represents distance or displacement, typically measured in meters, kilometers, miles, or other length units. The graph consists of points plotted on the graph, and each point represents the position of the object at a specific time. By connecting these points with a line, you can see the pattern of the object's motion over time. Interpretation of a distance time graph. Constant speed. If the distance time graph shows a straight line with a constant positive slope, it indicates that the object is moving at a constant speed. The steeper the slope, the faster the object is moving. Stationary object. If the graph shows a horizontal line at a specific distance, it means the object is not moving, its distance from the starting point remains constant over time. Rest and motion. If the graph consists of alternating horizontal and diagonal segments, it indicates the object is alternating between rest and motion. The horizontal segments represent times when the object is not moving, distance remains constant, and the diagonal segments represent times when the object is in motion. Changing speed. A curved line on the graph suggests that the object's speed is changing. For example, if the curve becomes steeper, the object is accelerating, and if it becomes less steep, the object is decelerating. Negative slope. If the graph shows a straight line with a negative slope, it indicates that the object is moving in the opposite direction. Negative displacement, with a constant speed. Example of shape of the distance time graph for the motion in the following cases. 1. A car moving with a constant speed. A car moving with a constant speed covers equal distance in equal intervals of time. Such motion of the car is represented in the given distance time graph. 2. A car parked on a side road. The distance time graph of a car on a roadside is such that with the increase in time, there is no change in distance, as shown in the given figure. Thank you so much for watching. Please like and subscribe to my channel LinkedIn Farmer.